Hello everyone, welcome to today's session on finding analysis classes. In this video, we will understand what analysis classes are, why they are important during the analysis phase of OIC, and the characteristics of good analysis classes. By end of this video, you will have clear understanding of how analysis classes represent real world business concept and support the development of software system. So first activity is a UP activity, analysis a use case. So before designing the software system, we first analyze the requirement. In the unified process, one important activity is analyzing a use case. During this stage, we identify the important objects involved in the problem domain and understand their responsibilities. These identified objects later become an analysis class which form the foundation for creating the system design. What are analysis classes? The classes are identified during the analysis phase is based on the use case model and system requirements. They represent meaningful concept from the real world business environment, for example, customer, product, employee or bank account. At this stage, analysis classes contain only the high level information which will be include some important attributes, some major services and responsibilities that class should be performed in the project. Detailed implementation is not considered during this analysis. The objectives only understand the problem before clearly moving to the system design. The next one is anatomy of analysis classes. Every analysis has several important elements. The first element is a class name, which is a mandatory and should be clearly describe the business concept. The second element is a attribute, which represent important properties of the class. During the analysis, only important attributes are identified and their data types are usually not specified here. The third element is operations or responsibilities. So it describes major services the class should be provide. And detailed parameters and return types are normally omitted here because the focus is only understanding the responsibility rather than implementation. And elements like a visibility, stereotypes and tagged values are identified here. It is for only the improving the understanding of the model. The next one is a anatomy diagram. This diagram illustrates the structure of an analysis class. At the top of the diagram is a class name and also followed by list of important attributes, and finally the responsibilities or operations are listed. This example structure helps the analyst to organize the information gathered during the requirement analysis and serve as a blueprint for later design activities. So this slide shows a example of one analyzed class is a bank account. Here the class name is bank account and the identified attributes are number, owner and balance, and identified the operations are deposit, withdraw and calculate interest. Next we discuss what make a good analyzed class. A good analyzed class should have meaningful and descriptive name that reflect its purpose. It should be represent a single concept from the problem domain and a focus on specific responsibility. A good class should have high cohesion, that is, all responsibilities are closely related to each other. At the same time, you should have low coupling. The meaning is it should depends on little as possible on other classes. Following these principles, it improves the software quality, maintainability and reusability. Okay, next we are going to be see the some rules for creating the analysis class. The first one, the class must be simple. That is, it should have 3 to 5 responsibility per the classes, and no class stand alone, and don't have lot of small classes with one or two responsibilities. Better try to merge them into the single class, and don't have the classes with more than 5 responsibilities, that may be reduced into smaller classes. This help the designer to create or implement the classes easily. Okay, so some other rules when creating the analysis classes are, the first one is we should avoid some functionoid, which are the classes are simply wrap single function without representing the meaningful business concept. For example, when we are having the calculate salary, suppose inside there is a function which calculate only the addition of the common pays is only used in that function. So avoid such a function is a one of the important rule. And second one is a reduce the omnipotent classes. That is, for one particular class is having all the functionalities like a login, calculate calculations, and issues, deliver everything in a single class is a very difficult to manage. So that class is called the God class. So it try to perform every task in the system. So that may be divided into many cohesive classes, means it will be very helpful for further analysis. And also avoid deep inheritance trees. Use only inheritance whenever it is needed, and the objective is very clear, means we can go. Otherwise avoid unnecessary inheritance. For example, car may be a child of the vehicle, but we are splitted into vehicle car, luxury car, and like that, means it will be very difficult in the further implementations. So avoid such a inheritance is also one of the important rule. Okay, so we come to the end of this video. So we come to this end of the session. So before we conclude, let us quickly review what we have learned in this session. We have discussed that concept of analysis class and understood their role in the representing important business concept during the analysis phase. We also explored the anatomy of the analysis class and the characteristics of good analysis class, along with some practical guidance for identifying the effective classes. These concepts providing the foundation for building the robust object-oriented analysis model. The next video we will be study the different techniques used to identify the analysis class, including non-verb analysis, CR analysis, and other useful sources for finding the classes. Thank you, and see you in the next section.